Okay guys, what we're going to have a look at in this video is writing chemical formula, something that seems to cause students quite a few problems every year, but it is vital. It's a common thread which runs through the entire GCSE syllabus, and you can be asked to write chemical formula and to write equations in pretty much every single topic within the GCSE specification. So it's not something you can learn as an entity on its own. You're going to have to make sure that you are able to apply it in every situation. Right, so before we begin this, guys, you're going to need a few pieces of a few resources. The first thing you're going to need is a periodic table. This is the CCA periodic table, which I have just downloaded off their website. You can do the same, just go to the CCA website. Okay, chemistry, find the data sheet for double award or triple award chemistry. The other thing that you will need, and it's just simply on the reverse of the data sheet, are these lists of positive ions and negative ions. Okay, that'll be very important later on. Okay, and the final thing that you will need is from your own class notes. It is a list of formulas that you need to know, and formulas that you won't be able to work out using the rules that I'm going to equip you with during this video. So you will need the formulas of all the acids, some diatomic elements, and just some other random formulas that you have to know off the top of your head. So these tables, it's really important, guys, that you've learnt these and you learn them well, because I'm going to teach you some rules which allow you to work out formula, but it won't allow you to work out these formula. These ones you must know off the top of your head. Okay, so make sure you got those stuff, that periodic table, etc. And the first thing we're going to do is we're going to start with the periodic table, and we're going to make a couple of little annotations on it, which I want you to do. And this will allow us very easily to work out the formulae of substances. Right, so you have group numbers along the top, 1, 2, 3, 4, 5, 6, 7, 0, etc. What I want you to do is just to write over here the word valency, or you can write the word combining power. Okay, and all I want you to do is write 1, 2, 3, 4, 3, 2, 1, 0. Okay, those don't mean a big pile to us at the minute, but they will do as we go along. Right, now this big group in the middle, which some of you may recognize as the transition metals, what I want you to do there is say that the valency, or the combining power, is equal to the Roman numeral or the charge number. Just write in brackets, ignore the sign. Okay, so for example, if we have a look at our ions that we have here, okay, when I'm talking about equal to the Roman numeral or the charge, ignore the sign. So if we look, let's say for example, at iron 3 here, the combining power or the valency of iron 3 is equal to the Roman numeral, which is 3, or the charge, which is 3. Ignore the sign, so the sign is obviously positive, just ignore that. Okay, likewise for some things over here, carbonate is CO3 is its formula, the charge is 2 negative, ignore the sign, so the combining power of that is 2. Okay, if we look at an ethanoate, the formula is CH3COO. The charge is minus, which means -1, so its combining power is 1, and we ignore the sign, we ignore the negative. Okay, so that's what I mean when I talk about Roman numerals. Okay, so we have 3, a 2, a 2, a 3, and a 2, depending on whether it's lead or iron 3, iron 2, copper, chromium. Just make a wee note that iron can have 2 different combining powers or 2 different valencies. Okay, so make sure you read the question, and we use iron 2 quite a lot. Don't just get it into your mind that we only have iron 2. Read the question carefully to make sure you know which iron ion we are actually talking about. Okay, so that's really important that you have got all of that information, guys, in front of you. Okay, and if you have all of that information in front of you, you are ready to go. I'm not going to keep going back to this periodic table. I'm putting it up on the screen. I'm going to assume that you have it. I'm going to assume that you've annotated everything on it as I have asked you to do. And I'm going to assume that you have this, and I'm going to assume that you have the table of formulas, which is in your notes, this table here as well. Okay. What you can do as we go along is just stop the video. I'm going to do a variety of questions as we go along. You can just stop the video and start it again and then check that you have got the correct answer. Okay, so first thing we're going to look at is writing formulas. So a lot of time when I'm teaching this, I ask the question, what's the formula of magnesium chloride? And I pretty much always get at the start of fourth form MgCl. Well, in actual fact, the formula of magnesium chloride is MgCl2. So a lot of people just do not know where this 2 has come from. Because if I asked you the formula of sodium chloride, it is indeed NaCl, whereas magnesium chloride, suddenly we need 2 chlorides. So why do we need 1 here and 2 here? Well, that's what hopefully by the end of this video you will be able to work out. So let's take sodium chloride then, just to begin with. Okay, so we'll write down our sodium and write down your chloride. That's what it's made up of. And then we go to our periodic table. We need to find sodium and we need to find chloride. So let's look at sodium. Sodium is in group 1. It has a combining power or valency of 1. So we just pop the 1 up there. Chlorine is in group 7 and has a combining power of 1. We pop the 1 up there. Okay, now all we do is we do our little, what I will call crossover arrows, and then we take that 1 and we pop it there, and we take that 1 and we pop it there. That now gives me a formula of Na1Cl1. Now hopefully you all know by now in chemistry that the 1s do not appear in a formula, so we just write NaCl. Now let's have a look at magnesium then, and magnesium chloride. So we go to magnesium, we find it here. The valency of magnesium is a 2, and the valency of chloride, which we've already looked at, is a 1. So we go back over here and we put our magnesium in, and we put our chlorine in. We put our 2 above the magnesium and our 1 above the chlorine. And again we'll do our crossover arrows. That means now we've got magnesium 1Cl2. Again, the 1 does not appear, so magnesium chloride has a formula of MgCl2. Okay, it's as simple as that. But you must remember these valency numbers. As long as you remember the 1, 2, 3, 4, 3, 2, 1, 0, and this little bit in the middle about Roman numerals, you should be able to do any of these that are given to you from the periodic table. Okay, so we'll have a look at a few more. So if we look this time at potassium, and we look at potassium oxide. So again, go to your periodic table, find potassium and find oxygen. Potassium group 1, combining power 1. Oxygen group 2, combining power 2. Crossover arrows. We go to K2O1, K2O. Potassium oxide has a formula of K2O. Okay, let's take something like calcium sulfide, CaS. Okay, calcium is in group 2, has a combining power of 2. Sulfur, group 6, combining power of 2 also. Okay, so we go Ca2S2. Cross over there, 2 goes there, 2 goes there. Now, new rule. We always represent these in the simplest whole number ratio. So 2 to 2 is the same as 1 to 1. So the formula of calcium sulfide, we would not write 2 and 2, we must write 1 to 1. Okay? If you write 2 to 2, you will lose marks. Alright, so let's have a look then at something like aluminium and fluorine. So aluminium is over here, it's in group 3, combining power 3. Fluorine over here, combining power 1. So aluminium fluoride, we do our crossover arrows, 3, 1, crossover, crossover, Al1, F3, aluminium fluoride has a formula of AlF3. Okay, so hopefully these are all clicking with you now. There are a whole load of these in your notes, guys, which you can have a go at. Okay, you've probably already had a go at them in class, but you can practice them again, check that you are on the right lines. Okay, let's have a look at a covalent structure, something called methane. Methane is a combination of just carbon and hydrogen, so if we find carbon is in group 4. Hydrogen is here on its own, and I haven't given it a number yet. Give it a 1. Okay, so if we do our crossovers, I'm not going to continue writing the 1s in, guys, because hopefully by now you are able to work out. Okay, so it's CH4. Alright, if we have a look at carbon dioxide, CO, carbon is 4, oxygen is 2, crossover arrows, C4, C2O4. Remember, our simplest whole number ratio goes to CO, C1O, to carbon dioxide, CO2. Okay, so that is how you write formula when you're combining anything which is on the front of this periodic table. Now obviously not everything is on the front of the periodic table, and a lot of the stuff that you have to write formulas for are in these data sheets on the reverse side of the periodic table in the examination. So we'll start using a few of these. Okay, so we'll start primarily with the left hand column of positive ions, and we'll start combining a few of the left hand column of positive ions with some of the elements from the periodic table. Okay, right, so let's first of all take the examiner looking for the formula of chromium 3 fluoride. So chromium has a Roman numeral of 3, and I said earlier that the Roman numeral told me the combining power, so chromium must have a combining power of 3. Fluorine is in group 7, combining power of 1. So if I do my crossover arrows, I get chromium 1, fluorine 3. So in other words, the formula of chromium 3 fluoride is CrF3. Okay, so that's pretty straightforward. Okay, if we take copper 2 oxide, we write our formula, copper and oxygen. It's copper 2, so combining power is 2. Oxygen is in group 6, so it's combining power of 2 also, therefore, so that's copper 2 O2. So in other words, simplest whole number ratio, formula of copper 2 oxide is CuO. Let's have a look at our iron. Remember, our iron, we can have iron 2 oxide and we can have iron 3 oxide. So it's important we know how to deal with the Roman numerals so we can get the potentially different formulae for these. So again, write out the formulas just of the substance iron and oxygen. Find out the combining powers. Well, that's obviously 2 and 3. Oxygen is 2 and 2. Do our crossover arrows. So it's a 2 to 2 ratio for iron 2 oxide, which is the same as 1 to 1. Here it's a 3 to 2, so it's Fe2O3. We can't simplify that any further because it has to remain as a whole number, So the formula of iron 3 oxide is Fe2O3. Iron 2 oxide is simply FeO. Okay. Right, let's go and find something like zinc. And we will do zinc chloride. Now there is no Roman numeral here, so this time we've got to go to our periodic table. Well, if we find zinc on our periodic table, it's here. So it's in this block where I've said about Roman numerals or charge. So we can't use the front of the periodic table. So we've got to go to the data sheet here. There's zinc, no Roman numeral, so we can't use the Roman numeral. We've got a charge of 2 plus. Remember I said just ignore the sign and use the number therefore. So zinc is combining power of 2. Chlorine is in group 7, is combining power of 1. Crossover arrows, Zn Cl2. So zinc chloride has a formula of Zn Cl2. If we do silver oxide, again no Roman numeral with the silver, and if we go and find our silver we will see it is in this block here. Okay, it's just here, so we can't use the combining power numbers at the tops of the columns. We've got to go to here. Silver, no Roman numeral as I said, but it has a plus charge. Plus means plus 1, so silver is a combining power of 1. Oxygen's in group 6 and has a combining power of 2. We do our crossover arrows and we get Ag, 2 goes there. Oh, there's a 1 there, but again we don't write that in. Okay, so hopefully we're all starting to get this, guys, and feeling a wee bit more comfortable. Those are all very simple ones. Okay, right, so this time what we will do is we'll bring into play, in fact we haven't done any ammonium ones, so we'll do some ammonium. So ammonium is our first experience of what we call a polyatomic ion, and whenever we say an ion just simply means charge, and you can see in the ammonium it's plus 1. Okay, polyatomic means that there are several atoms. So unlike our earlier ones where you had zinc and we had copper and we had silver and we had iron, these are just monoatomic. There's just one atom per ion. Okay, whereas here now we have nitrogen and hydrogen, both NH4 positive. So let's see how we deal with these. We'll take a nice simple one first, and we'll do ammonium chloride. Okay, so that's plus, which means plus 1. Okay, so therefore the combining power of ammonium is 1. Combining power of chloride is in group 7, so it's also 1. Crossover arrows, so ammonium chloride is simply NH4Cl. Very, very simple. Okay, we'll do ammonium oxide then. Again it's 1, oxygen is 2, so it's NH4. We need 2 of them, 2 down to there. Oxygen. Now we need to be careful here, because what I've written here means I have 1 nitrogen and 42 hydrogens, but what I need is 2 ammoniums. So how do I get 2 ammoniums? Well, when it's a polyatomic and you have more than one of them, you have to put that into brackets. So ammonium oxide is NH4 twice O. Okay. And if we have ammonium NH4 ammonium nitrite, again that's 1, that's 3, or 3 goes to there, or 1 goes to there. So it's ammonium nitride, NH4 3 times N. Okay, so always remember, this is where people lose marks all the time, guys, is forgetting to put these brackets in. Okay, you might say earlier, well, why did I not need brackets when I had iron oxide, iron 3 oxide? Why did I not need brackets there or there? Well, that's because this little 2 just refers to iron only, so there's no need for brackets. It's not referring to anything else. Whereas when you have ammonium, you must have 1 nitrogen and 4 hydrogens. Okay, so they all have to be multiplied by whether it's a 3 or a 2 or whatever number it happens to be. Okay, So we're moving into the last little bit here, and we're going to start, as I said, using the column of negative ions on the back of your periodic table, on the back of your data sheet. Okay, so key thing about these is, guys, that a lot of students here will drop marks because they forget to differentiate between the charge and the formula. The formula of a carbonate is CO3. So if you have sodium carbonate, you will always have CO3. This charge does not appear in the formula. Likewise this, etc., etc. The charges do not appear in the formula, and that is really important. Okay, so a dichromate, for example, has a formula Cr2O7. That's all that will appear in the formula. The 2 negative disappears when it comes to writing the formula. We use it to get the combining power, but when the formula is written, it's gone. Likewise, an ethanoate is CH3COO. The minus or the -1 does not appear in the final formula, and that is really, really important. So for whatever reason, students forget to either don't put this 3 or this 7 or this 2, etc. into the formula, or maybe they do keep the charges in. Okay, if you do that, you will lose marks. Okay, so if we have a go with a few of these, so we will take a nice simple one. First of all, we'll take potassium. And we'll take potassium ethanoate. So ethanoate is CH3COO minus, so it's -1 is what we're saying there. So in other words, we ignore the charge and we give it a combining power of 1. Potassium has a combining power of 1. So if we do our crossover arrows, potassium ethanoate simply got a formula of KCH3COO. Okay. If we take something like magnesium ethanoate CH3COO, well, that's -1, so it's combining power of 1. Magnesium is in group 2, so this time we go Mg1 there, CH3COO. Now you can put the 2 there, but you cannot leave the 2 there without doing something. Okay, hopefully some of you know what to do now. Remember, this is polyatomic ion, so we've 2 of them. So if I had left the 2 without the brackets, I would just say 2 oxygens, but in fact I need 2 of everything, so I must use brackets. Okay, let's have a look at then something like iron 3 carbonate. Well, the Roman numeral tells me that the iron has a combining state of 3. Carbonate is CO3, and it's a CO3 2 minus, so the combining power of it therefore is 2. We do our crossover arrows. We have Fe, we need 2 of those, no brackets required because it's just iron. Carbonate CO3, this is a polyatomic ion, we need 3 of them, so iron 3 carbonate is FeCO3. That's the formula of the carbonate. The charge does not appear in the equation, and a 3 there. Okay, let's have a go at calcium nitrate. Calcium is in group 2, so we won't find the formula of both things. The nitrate on the data sheet is NO3, and if you look at the charge, it's minus, which is -1, so it's combining power is 1. Calcium is 2. Do our crossover arrows, Ca brackets, NO3, 2 of them required. Okay, let's have a look at lead. That's 2, sorry. Lead 2 sulfite. Okay, so lead is Pb. 2 is Roman numeral, tells me the charge. The sulfite then is SO3 is its formula, and its charge. Okay, so formula is SO3. Okay, and its charge is 2 negative, so its combining power is 2. Okay, do our crossover arrows again. It's Pb2 brackets SO3 2. Hopefully you recognise now that that is not as simple as whole number ratio and has to be changed to Pb SO3, and in actual fact we don't need brackets for lead 2 sulfite at all. Okay, let's do your last couple then. Aluminium hydroxide. Aluminium is in group 3, combining power of 3. Hydroxide, if we look, has a charge of minus, which is -1, so it must have combining power of 1. Crossover arrows. Aluminium hydroxide is Al brackets OH 3. We need 3 hydroxides. Okay, we'll have a look at potassium dichromate. Dichromate Cr2O7. Okay, if we look in the data sheet, it has a 2 negative charge, so it's got a combining power of 2. Potassium has a combining power of 1. Okay, so K2 Cr2O7. Okay, potassium dichromate. If we look at chromium 3 sulfate this time, so sulfate is SO4 and its charge is SO4 2 minus. Chromium, our Roman numeral tells me the combining power of that's 3, so it's 2 minus, so its combining power is 2. Again we do our crossover arrows, so we go Cr2 SO4 3, there's 3 of them, so they've got to go in brackets. So chromium 3 sulfate Cr SO4 3 times. Okay, last one guys, we are going to do iron 3 dichromate. So iron is Fe, dichromate is Cr2O7, and remember Cr2O7 2 minus, so it has a combining power of 2, and that is 3, so our 3 under 2 is Fe, we need 2 of them. Dichromate Cr2O7s, we need 3 of them. Iron 3 dichromate has a formula like so. Okay guys, well you know that is how you write formulas. When we're writing balanced symbol equations, we will use this here, this table, more than we did today. In actual fact, it wasn't really necessary for just writing formulas, but in our next video, writing balanced symbol equations, it will become very important. Okay, I hope that helps. There's lots of worked examples in your notes. There's lots of websites that you can go to. Just Google writing chemical formula or something like that, GCSE, and you'll find lots of places where you can test yourself and get immediate feedback on how well or how poorly you are doing at this. Okay.